Hey everybody, welcome to FarmCraft. In a previous video I tore down a water heater and now we're going to move on and make a chicken scalder out of it. We butcher our own chickens and a chicken scalder is used to loosen the feathers prior to plucking. After you've killed the chicken, you dunk it in water that is about 145 degrees for about 30 seconds, and that loosens the feathers and makes plucking much easier. So first I need to fix the small hole that's in the bottom of this water tank. Alright, so I tacked on just a little bit of a bead. Now I'm going to go on the other side and I'm going to put some epoxy in there to protect that weld from rusting out. You can see right there is the weld bead. So I'm going to clean that area up with a wire brush and then I'm going to put some waterproof epoxy around it. So this is some stuff called Mighty Putty. I wouldn't trust it with anything that's like critical, but I just want this thing to not leak very much. If it leaks a tiny bit, it's not going to matter. So it comes in this tube. It's got two parts. There's an inside and an outside. You just take the two and you mix them together. Once you get a consistent putty out of it, you're ready to apply it. The nice thing about this stuff is that you can use it immediately. I've even applied this on a cattle waterer that was leaking but was in use. It was full of water and I just reached down in there with the putty and stuffed this in the hole and it'll set up even underwater. I can't really get in there without blocking the view. Alright, I covered that up pretty well. The bottom thermostat and heating element are perfect to control the temperature of the chicken scalder. I just have to hook power between this point and this point. See the previous video to have a better understanding of how all this works. Alright, I'm going to do my connections here. I've just got the end of an old extension cord. You definitely want a good ground because if anything shorts out, this whole tank is going to get energized, so you want the current to overload and pop the breaker. I found this fitting. It goes from 3/4 inch pipe thread to garden hose. So I'm going to put that here, and that's going to make draining this a lot easier. I had to push so hard, it's now an oval shaped pipe. The cool thing about this is all this needs to do is maintain a temperature. If it takes a little while to get up to temperature, that's fine. So I don't think I need to run this at 240 volts. I think I can just plug this into my standard 120 and it should work. That'll make it much more convenient. I can just plug this into any extension cord. So I'm going to test that in just a minute. I need to figure out a way to waterproof that without interfering with the functioning of the thermostat. Something that will cover all that so that if water splashes down it won't matter. I've got this antifreeze container that should work very well. Hook on top of this thing, and these are going down behind those ears there. If a tiny little bit of water gets in behind that, it's not going to matter because it's just going to stay on the tank and then drip out. It's not going to get to the electricals. So yeah, there you go. I had these wire trays laying around and I used copper and then some copper tubing to make something that would fit right in the center there, kind of wedge in place. That way when you're dunking a chicken, you're not going to do anything to that heating element. You wouldn't want this to be a solid piece because then the water would get really hot underneath and it wouldn't be able to come up through. I'm at 57 degrees in there, so let's plug it in. Okay, here's the plug. We are plugged in. So I do hear something. Usually when a hot water heater kicks on you hear a little more than that, but this is running at half voltage, so that may be why. It's definitely going up. Took my cover off just to make sure everything looks okay, and I wanted to check the amperage. And if you put this inductive type amp meter around one leg of your circuit, it will tell you how many amps you're getting, and it's 9.8 amps. So if I was at 240 volts, it would be double that. But it's definitely working, and I've set a stopwatch. Let's see how long it takes to heat that water up. Alright, we're coming up on 10 minutes. Ugh, and we're only at 62. So that's going to take a while to get to 145, isn't it? Alright, we're just over 25 minutes. And we are at a whopping 68.1 degrees. That is really slow. And I realized that I made a mistake in my calculations. This heat element is not doing what I thought it was doing. Let me show you. So I am drawing 9.8 amps at 125 volts. And when you multiply those out, that gives you your wattage. Well, that's only 1200 watts. This is a 4500 watt. This is the other heating element, but they're the same. 4500 watts, half of that would be 2250, not 1200. So it's like I'm only running at quarter strength. Why would that be? Well, of course, it's because I've dropped my voltage. If this was running the same amount of current at half the voltage, then it would be half the power. But because my voltage is less, the resistance hasn't changed, my current is half. My voltage is half, resistance is the same. Your current is voltage divided by your resistance, so my voltage has dropped in half, so my current has dropped in half. Well, my current has dropped in half, and now my multiplier for my power has gone from 250 to 125. So I'm actually running at 1/4 strength. I measured, I've got about 19 inches of water in there, it's about 18 inches around. That comes to this many cubic inches. It's 21 gallons I have in there. 8.3 BTUs to raise 1 gallon of water 1 degree. I'm trying to go from 57 to 145 degrees, so I got to go up 88 degrees. That means 8.3 times 88 for each gallon. So it's 730 BTUs per gallon that I need. I've got 21 gallons, so I need 15,338 BTUs. That's assuming no losses, which of course there's going to be plenty. It's not even insulated. There is 0.000293 kilowatt hours per BTU. Multiply that out, it's 4.5 kilowatt hours. Well, I'm only drawing 1.225 kilowatts, so you divide it. It's going to take 3.7 hours to get up to temperature with my current setup, and that's assuming no losses. That kind of sucks. This is an extension cord that I use for various things. I actually originally set it up for my electric kiln, but it has a 220 volt plug-in. I've got several outlets like this that my tools run off of. I usually use the one for my compressor, and I just ran it to a regular end. No, that's not code, but I'm using common sense. I know this is plugged into 220, so whatever plugs in here needs to be able to handle it. Well, this can, so I'm going to change this over to 220 volts. I don't hear much, but I definitely do see a lot more bubbles coming up off of it. My timer is at 32 minutes. We just changed over, and we are at 72 degrees. Can you hear that? In the distance there, can you hear it? Yeah, that's the safety Nelly screaming that I'm going to kill myself. Hush up. Just don't touch anything that's got voltage on it. Let's check our amperage. 18.6. So now I've got 18.6 amps times 240 volts equals 4,464 watts. Place this one with 4464 and you can see it's about an hour. The reality is, when I want to use this thing, what I'm going to do is heat up a couple big pots of water on the stove and dump it in so that it doesn't have to heat the whole thing from 57 to 145. Basically all it will be doing is maintaining. It has been 10 minutes at the 240 volts and we are at 93, 92. Heating up a lot quicker with that. 4 times as quick, in fact. So we are at 62 minutes and this is reading 123. My non-contact is reading 128. I just want to make sure that the thermostat is set so that it will actually reach 145. It would be a real shame if this thing kicks off at like 140. Alright, we're at 72 minutes, about 141 degrees. Non-contact says the same. And we're still heating, so this is not going to have any problem, I don't think. Hope you guys enjoyed. Thanks for watching.